Hello dear students, welcome to the lecture number 4. In the previous clip, you understood the electric circuit, components of electric circuit and Ohm's law respectively. Here we are going to discuss about the experimental verification of Ohm's law, factors affecting the electric resistance and the concept of resistivity. From the experimental part, I was thinking to bring a practical approach to the ongoing video lecture, but it will take some time. Okay, anyway, I am doing that work for you people. Let's move on to the experimental verification of Ohm's law. Since it is the practical part, we are always having the terms in a systematic manner. First, we need to set out the aim to study Ohm's law, later the requirements, then the circuit diagram, procedure, observations, calculations and results respectively. This is the pattern we are following in doing the practicals. So the aim is fixed right now. And next, that is the requirements for study the Ohm's law. We need a wire of high resistance. So generally a wire of high resistance means we need to maintain the resistance of suitable value, or that value can be analyzed by the students. Therefore, we are bringing the wires of high resistance such as nichrome or constantan or manganese. These are the few materials we are using as a high resistance source. Next requirement will be voltmeter and a milliammeter plug key, battery, rheostat as a variable resistor and connecting wires. Now let us draw the circuit of Ohm's law. That is circuit diagram we are mentioning. As I was saying that these are all the materials we are using in framing the circuit. So let's go on drawing the circuit diagram. This is the battery. This is the key, and this is the variable resistor or rheostat, and this has to be the wire of high resistance. The value we are going to calculate for this wire of resistance R. This is having the plus minus B a battery. This is plug key K, this is rheostat, and this end has to be connected with variable resistor or rheostat. And in between we are using an ammeter plus minus and a voltmeter across the resistance wire. So this is the circuit diagram for verifying the Ohm's law is concerned. Part of procedure. So first step is to connect the circuit in accordance with the diagram. switch on the circuit by closing the key. By that, the current starting to flow inside the circuit. Once we switch on the battery or plug key here, so you are going to observe the deflections in ammeter and voltmeter respectively. You are definitely having the deflections once the circuit is correctly arranged. So you just read the voltage V values and A values respectively. So next step is to bring back the values of deflections in voltmeter V and ammeter A back to 0 using variable resistance RH, the rheostat. So after getting the 0 setting right, now note down the values of note down the values of voltage and current respectively. So the observations chart come into play. Observations are as follows. So serial number 1, voltage, we are measuring V in volt. Next, current in I in milliampere. Therefore, resistance can be calculated as R is equal to V by I. Since we are having milli on the bottom, therefore it has to be multiplied with 1000 here. Therefore 10 to the power 3, it is measured in ohm. So initial readings 0, 0 after getting the settings right. Second point, let's assume that you are having around the voltage of 0.1. You are having the current around 20 milliampere. This is the first reading. Let's imagine in such a way that we are having the proper observations and hence we are calculating the practical values. Third one, for 0.2 volt, we are having 40 milliampere of current. For 0.3 voltage, we are having around 60. Fifth one, 0.4, 80. And sixth one, 0.5, 100 milliampere. Let's imagine we are having the readings like this. So we need to calculate the resistance according to those values. Let's calculate those. So calculation part. So for first reading, resistance R is equal to V by I into 10 to the power 3, which is equal to, since the voltage and current is 0, this part will be 0. For the second set of reading, R is equal to, first V should be 0.1 divided by 20 into 10 to the power 3. So which is equal to simply 1 by 10 into 20, which is into 10 to the power 3, which is equal to 1 divided by 200 into 10 to the power 3, which is equal to 1000 divided by 200. Therefore you left out with 5, and hence for the first reading that will be R is equal to 5 ohm. This is 0, now this is 5. Now let's go for the reading number 3. R is equal to 0.2 divided by 400 into 10 to the power 3, which is equal to, again if you solve that you left out with 5 ohm. If you calculate 0.2 by 40 into 10 to the power 3 leaves you 5 ohm. Similarly, all other readings are coming as 5 ohm respectively. So you write the column 5, 5, 5, 5. Now if you ignore this part and take the mean part of this, you left out with R is equal to 5 ohm, and hence the resistance of the wire which is used, that is 5 ohm, and hence you have to write the result. So resistance of the given wire, resistance of the wire R is equal to 5 ohm. And also note that this can be done instead of taking the mean or average, you can do it with the help of graph too. Now let us move on to the next part, that is factors affecting the electric resistance. So what are those factors affecting the resistance? We need to understand at this point. So electric resistance of a conductor or wire depends on the following factors. Number 1, length of the wire, length of the conductor or conducting wire. Second one, area of cross section of the wire, area of the cross section of the wire. Third one, nature of the conducting material, nature of the conducting material. And fourth one will be the temperature. So these are the factors which are affecting the electric resistance. Let's study these factors one by one. So first one will be the length of the wire. How length affect the electric resistance? It has been found experimentally that electric resistance affected by the length directly. Okay, directly means length of the conductor L, which is directly proportional to R, or R, the resistance of the wire or conducting wire, is directly proportional to length. This is proven experimentally, or many experiments done. So we conclude that from those experiments R is directly proportional with length L. Which means what? If you increase the length of the wire, if you increase the length of the wire, what is going to happen? Resistance is going to increase. Resistance increases as the length increases. Resistance increases. If you decrease the length, then resistance decreases. Okay. Now, second part, that is the area of cross section of the wire. So, just like length, area of the cross section of the wire is also affecting the electric resistance, but this is in inverse relation. Say 1 by A means if the resistance and area are related inversely, means one is increasing means other one is decreasing. Say if you increase the area of cross section, if you increase the area of cross section, resistance is going to decrease. If you decrease the area of cross section, resistance increases. Okay, let's move on to the effect of nature of the conducting material. How the nature of the conducting material affect the electric resistance. See, for example, if we take two similar wires of equal lengths and equal diameters, say one is the copper and other one is the nichrome as the alloy, one is metal and other one is alloy. If you take those two materials together having same length, same area of cross section, it is found that nichrome wire's resistance is almost 60 times more than the copper wire. Keep in mind that this is a very large value. In the metal like copper having a high current means low resistance. So nichrome having the 60 times far more than the copper wire. So this is how the nature of the material is affecting the resistance. And last one will be the temperature. So if you increase the temperature, resistance is going to increase. If you decrease the temperature, resistance is going to decrease. So these are all the factors which are affecting the electric resistance. We are heading to the next part, that is the concept of resistivity. As we are already know that the resistance of the conductor is directly proportional to length, call this as equation number 1, and resistance of the conductor is inversely proportional to the area of cross section, call this as equation number 2. Now combining equation 1 and 2 respectively, combining equations 1 and 2, it can be written as R is directly proportional to L and inversely proportional to A. Now if you remove this proportionality constant, you leave with a constant of proportionality rho L by A, where this rho is known as resistivity of the material or conductor, resistivity of the conductor. So you call this as equation number 3. From equation 3, it can be written as rho is equal to R into A by L. You call this as equation number 4. Rho is equal to R A by L. If I am taking A is equal to, or better you call L is equal to 1 meter and A is equal to 1 meter square, then equation 4 takes the form rho is equal to simply R into 1 by 1, which is equal to simply R, and hence rho is equal to R. Rho is equal to R after getting the length L equal to 1 meter and A equal to 1 meter square. From this we are going to define resistivity. Resistivity is defined as the property of the conductor numerically equal to the resistance of length 1 meter and area of cross section of 1 meter square, which means electrical resistivity is numerically equal to electric resistance if the length is 1 meter and area of cross section is 1 square meter. Now SI unit of resistivity rho. SI unit will be, it is very simple. We are already having the equation number 4. From 4 it can be written as resistance is measured in ohm, whereas length meter square, area meter square, length meter, therefore ohm meter, and hence SI unit will be ohm meter. It is written as ohm meter. That is the SI unit of resistivity. Note that resistivity of the conducting material does not depend on length and area. Remember, since rho is equal to R, it does not contain, after making equalization 1 and 1, it does not contain any length or area. It depends only on nature of the conducting material as well as the temperature. Resistivity of alloys generally more than the metals. Ends the lecture number 4. Thank you for watching.